Hi friends, in the previous video you have seen how to generate the pulse amplitude modulated signal and how to demodulate the generated pulse amplitude modulated signal. Now in this video you are going to see how to calculate the bandwidth of pulse amplitude modulated signal. Let us consider the output waveform of PAM signal. This PAM signal waveform looks like a sampled waveform. So we can say that the sampled waveform can be represented in terms of sampling time period or a sampling frequency. Let us say that the sampled time period is Ts. Okay, and here we are assuming the on time pulse duration is tau, and similarly the off time pulse duration is also tau. So here the on time and off time pulse durations are same, and if you consider the total time period of the pulse duration is 2 tau. Now here we are making a necessary assumptions in order to find out the bandwidth of PAM signal. The first assumption we are considering is the pulse duration, whether it may be an on time pulse duration or an off time pulse duration. So the pulse duration of a PAM signal is always less than the time period of a sampling signal. So here I am considering on time pulse duration. So the on time pulse duration is always less than the sampled time period. So this is the first assumption we are making. And the second one we are finding is, we know that the message signal, okay, so the message signal is having a maximum frequency. Let us assume that the message signal is having a maximum frequency of FM. Now, since the signal looks like a sampled signal, the relation between sampling frequency and the maximum frequency is, from the sampling theorem, we know that the sampling frequency is always greater or equal to twice that of a maximum frequency. Here, this FM is nothing but a maximum frequency signal. Okay, so from this we can write Fs is always greater than twice that of maximum frequency, and here the maximum frequency we are assuming it as Fm. Now we can write Fs in terms of time period is 1 by Ts, which is greater than or equal to 2Fm. So if you write the reciprocity, then it is tau s is always less than or equal to 1 by 2Fm. So this is the second case. So from 1 and 2 we can clearly say that from 1 and 2, by observing, we can say that the on time pulse duration of PAM signal is less than Ts, which is less than or equal to 1 by 2 Fm. So this is the relation, means the on time pulse duration is always less than a maximum frequency signal. Now from the waveform we can write the maximum frequency signal is F max is equal to on time plus off time, that is 1 by tau plus 1 by tau, which is equal to 1 by 2 tau. Okay, so this is number equation 3. So we know that the bandwidth of a transmission signal is always greater than the maximum frequency of a PAM signal. So the bandwidth of further transmission we are considering, which is always greater than F max, implies the bandwidth for the transmission signal is always greater than 1 by 2 tau. So we know that this tau is nothing but the on time or off time pulse duration. On or off pulse duration. So this is the procedure how we are considering or how we are calculating the bandwidth of a PAM signal. Thank you.